Okay, calculus folks, here are a few examples. Go ahead and see if you can try these on your own, these exercises. I will just sort of pause here for a second so that you can pause the video yourself and try these out. And then I will go ahead and go through these in a little more detail. So for the first problem, you should get an answer of, it's going to give us an answer of 21. For the second problem, you should get an answer that is equal to e minus 1 over e plus 2. Put some boxes around these. And for the third problem, you should get an answer of negative 11.25. Exactly. So let's go over how you can do these problems. Okay, now that you've checked, if you want to pause again, if you got them wrong, you can go back and try to figure out what you did wrong. I'm going to sort of describe how you can do these here. Just in brief. So this first one, first of all, we haven't really talked about how you might be able to integrate a composition of functions like this. We will discuss that later. But for now, what you might want to do is actually go ahead and multiply that out. Like that. Okay, x squared plus 2x plus 1. Then, now we can just apply the fundamental theorem here. Let's find an antiderivative. 1/3 x cubed plus x squared plus x. And then evaluate that from 0 to 3. And that's what gives us our 21 there. Okay. For the second problem, we've got e to the t plus 1. Okay, and this is dt, right? So how would we find an antiderivative of e to the t? We've talked about this before. The antiderivative of e to the t with respect to t is going to be itself, because it's its own derivative. If it's its own derivative, it's going to be its own antiderivative as well. So that first term, it's just going to give us e to the t, and then for the second term we need plus t. So there's our antiderivative. You can check. The derivative of e to the t plus t with respect to t is going to be e to the t plus 1. So then we take that and evaluate it negative 1 and 1, and so we're going to have like e plus 1, and then minus e to the negative 1 minus 1, and this all ends up being our e minus 1 over e plus 2 when we're done. So that's how you can do that one. For the third one here, you notice that I put the limits of integration with the larger number at the bottom, which is interesting. So one thing you could do is flip this upside down right away and put a negative in front of it, but there's no particular need to do that. All right, there's no particular need. What have we got here? This is integral from 8 to 1 of x to the power 1/3. So we can just apply the anti-power rule on this and get x to the power 4/3. When you add 1, there you get 4/3. Then we've got to divide by 4/3. That's going to give us 3/4. Okay, now we're going to evaluate this at 8 and at 1 and subtract. And now, since we're going to be subtracting here, let me write it out. We're going to have 3/4 times 1 to the power 4/3 minus the 3/4 times 8 to the power 4/3. Okay. Now that we're subtracting, it's pretty clear why swapping the order of the limits of integration is going to change the sign. Because if you take a subtraction and you swap the order in which the terms are subtracted, that makes it negative, right? Or makes it positive. It makes it opposite. So flipping the order of subtraction and putting a negative sign and flipping the limits of integration, that all kind of like makes sense, right? It all kind of clicks together. So here, if you evaluate this, you get your negative 11.25. And that's that one. So there are some examples. This is just sort of basic applications of the fundamental theorem by finding antiderivatives and then evaluating at the endpoints and doing a difference.